All right, let's get started for today. All right, today's lesson is going to be going over distance and speed and time as referred to on a graph. So today you are going to be getting a copy of this right here. Let me change my screens. Give me just a minute, you guys. There we go. Got to be able to see what I'm teaching you. All right, so today we are going to get this in a digital format that you guys can actually print out to use at home, or if you're here in class, you're going to just follow along with me. All right. So, first thing we need to remember is we've talked about three things this past week. We've talked about speed, velocity, and acceleration and the difference between them. And speed tells us how fast, velocity tells us how fast with the direction, and acceleration tells us if the change. So speeding up, slowing down, or changing directions. All right, so now we're going to take all that information and we're going to put it in graph format. So follow along with me, and we will go through what all of this craziness actually means. So first off, this is what we call a distance time graph. So we have an object's distance on this y-axis, and we have an object's time on the x-axis. Now, when using a distance time graph, we can actually calculate the speed that an object would be going, because we can use distance divided by the time it took to get our speed. So a distance time graph is actually a very handy item. All right, let's move down the page. Okay, so this distance time graph has a flat line. I want you to think of like those doctor shows where the person's in there, their heart is beating, and then they say, oh no, they have flatlined. That means the heart is no longer pumping. It's no longer in motion. So a distance time graph that has a flat line means that the object has taken a break and is at rest. So in your notes, add these words, no motion. So think flatlining. Beep. Time is still going. Life is still happening, but the object is not moving. Okay, let me turn my pages here for us. Let me move over. There we go. Okay, let's look at this top one up here. Again, we have a distance on the y and time on the x. This graph is showing an object that is traveling at a constant speed. So for every meter it goes, it takes a second. Meter, it takes a second. Meter, it takes a second. So this graph represents moving at a constant pace. And then when we look at our second one right here, you'll see we have two graphs. In this case, our dotted line is higher than our straight line. What this is telling me is they are both moving at a constant speed, but the dotted line is moving at a higher constant speed, and the straight line is moving at a normal constant speed. And by higher, that means quicker. Okay, they're both still constant, it's just one is going faster than the other. And then our final graph in a distance time graph is going to be one that shows acceleration, or what we call an increase in speed. So notice the item looks like it's going constant, then it turns upward, which means the object began to speed up. If our object was slowing down, we would have what we call negative acceleration, or we say decelerating, which means to slow down, but it's actually called negative acceleration. So we have a constant speed, and then the object begins to plane off, meaning they are slowing down. If we put all of these things in a graph together, it starts to look a little confusing, but let me focus that. We see here, we have a nice steady speed of object A. We'll call the curved line object B. Notice it's going upward, so they're speeding up. And then object C is a steady pace. Then we flatline, beep, no motion, no heartbeat. And then it goes down the graph, which means we're returning to the place where we started at a constant speed. Okay, so now this is the part that's probably going to confuse you guys. There are speed time graphs we also look at. And it's more or less a memorization thing than any other thing you have to do is just memorizing the difference between the two. So here we have a speed time graph. Looks the same, means something different. So we have speed on the Y, and we have time on the X. So speed is the only thing that's changed here. Excuse me. Which means our distance is what we were plotting. Now, when looking at this type of graph here, because we've changed this to speed, we can now use a speed time graph to figure out how far an object actually went. So, looking at this right here, it means they went a constant rate of change, okay, or constant distance. So, they're going the same speed and time is ticking. So they're moving at a constant rate of distance over time. All right, so let's look at this one. Again, we have speed on one side, time on the bottom. Our angled line now is distance, but in this case, the object is speeding up. Or, excuse me, accelerating in distance, okay? So it looks very similar to constant on the other one, but in this case, acceleration. And lastly, we have the speed time graph with the line going backwards. So it's like we're at the end of the race and we're moving back towards the starting point. And this is negative acceleration, or what we call deceleration. And like I said, it's just memorizing the difference between the two. If you have to make flashcards or whatever it is that you have to do to memorize the slope of these lines. And then here we have a speed time graph. This line represents an item that is going quicker than the item here. Okay, so it's accelerating much quicker than this item. And last, when you put them all together, we have steady acceleration, steady speed, acceleration, and then deceleration. So you're going to use these graphs today to help you with some questions. I'm also going to put a picture online of these graphs like this to help you memorize the difference between the two. So I will take a picture of this and put it online. And then I will also take a picture of a distance time graph and put that online for you as well. And those of us in class, I'm going to pause this and we are going to copy our distance time graphs. So you're going to need one page broken up into 4 different areas. And then again, we're going to need a second page broken up into 4 different areas to do our speed time graphs. Okay? So if you have any questions, let me know. But again, like I said, it's all about memorizing. Every bit of this is about memorizing. Okay, you guys? All right. Good luck. Get those questions answered. Have a good day.